So today I'm going to show the process of printing, starting with creation workshop for slicing into the Kudo3D software, and then maybe a time lapse of the actual printing process. So what I'm going to be printing today is this iPhone bumper case here. And you'll notice that, hey, I've got one printed on the build plate here. But this didn't come out quite right. There was a couple of flaws here. So I want to first describe how I even got to this state where I'm 90% of the way there, what I changed, and then we'll go through and plug in the software. So when we print on the Kudo3D, right, we're printing with the bed kind of facing towards you, kind of like this, right? And there's a vat, and the vat is kind of underneath it, right? And so we rise, the piece part will rise out of the vat like this. Now the vat is held on one end, right? There's the stationary end back here, and there's a free end back, and then as you'll notice if you ever printed with it, there's the vat flexes. The vat will flex up and then it'll snap back down. It'll flex up and then snap back down, right, each layer. And that means that the separation forces between the front and the back of the vat are not the same. The forces in the stationary end, the back of the vat, are much higher than the forces in the front of the vat. What that means is, you'll notice that I've created this part here, and this part is angled around the X and Y axis, 10 degrees X, 10 degrees Y. And the reason for this is so that we reduce the cross-section against the printing area, and so that we don't have this massive cross-section and we get massive separation forces. This kind of distributes the separation force more evenly over the duration of the print, and the lowest point in the print, which is this corner right over here, this front corner here, is what's going to start. And this is the corner then that is deliberately placed as far away from the back of the vat as possible. This is to minimize the separation force, maximize the chance that we adhere. Once we have this part successful, the rest of the print is a lot more forgiving because everything becomes more and more attached together. So the whole part becomes more and more kind of solid. And so as we head towards the back where there are greater separation forces, the part still holds together because the separation force in the back is kind of distributed across all of these supports, as opposed to the very beginning, we're only held on in the front here. We don't have as much space to distribute off of. And this was one of the findings. You didn't see all of the failed prints that I had trying to get the starting point was here, the lowest point. Trying to get this to print. Originally, I had this flipped around 180 degrees where this lowest point was in the back, and I just couldn't get it to print, right? Rotating at 180 degrees and fixing up the supports improve things a lot, such that I am kind of 90% there. But we see here that there is a problem in the back corner. And in the back corner, this support here did not print properly. It got up about a couple of millimeters, and then the support failed. You notice that even though the support failed here, we've still got a full integrity part. And kind of what happened was, there might not be enough light for you to see this clearly, but you'll see that there's still a whole bunch of stuff here. We kind of eventually picked up the stuck-on bits in the vat, adhered it to the body of the model, and the model was able to print, because this is a 10-degree angle here that's relatively gentle. We can easily handle overhangs in an SLA printer of this angle, and so we still printed. But because there's no support, or rather the support in this whole corner is gone, we can see that the warping forces here have warped the part. right? And so the part here is not quite as good as the rest, whereas when we're held on by nice and even dense set of supports here, everything around this side, everything around this side is nice and even. I don't have any warpage of the thickness of the wall, even in my my entry point here. But here, there's a bunch of warpage from the vat. You'll see that, right? We print this way, so you imagine what the vat force is doing is it's pulling down, right? It's pulling away from the build plate. And since there was no support here to hold this up against the build plate until we had kind of a critical mass of support coming in from the side, from the body of the part, the separation force pulled this corner down. And so what I need to do is fix up the supports here, make this a bit stronger, make the base a bit stronger so it's less resistant to having failure at the beginning. And this is, of course, the side, right? It's in the back. This is the side that's going to have the greatest separation forces. I probably also don't need quite so much support, especially this mass of support that I have on these interior overhangs. And so I can probably dial back the support a bit. And I had the support dialed up really aggressive because I was printing this corner on the other side, but right 180 degrees rotated. And even with the support density maxed out here, it simply wasn't strong enough. I can't really start on the stationary side of the vat. So now that I have this here, I can kind of reduce the amount of support all over because I don't think I need quite this much support here. Got to firm up this part, and then after reducing the support, I'm going to have to increase the support density in this corner here to make sure that I still get good adhesion. Another thing I notice is I'm printing here with at about 75 micron XY resolution and 75 micron Z layers. And I can see that there's still some strands here, so I might try printing at 50 micron Z. And then the print was kind of slow. It took about 3 hours, and I noticed that I was Z lifting way more than I needed to. I can reduce the amount of Z lift at parts, and I could probably lift faster later than later on in the part, particularly once this part is solidly attached, starting at about maybe layer 100 all the way up to layer 566, which is the top here. And there's going to be more layers now that I go up to, if I change it to be 0.5. But you know, as I go up higher, then I can probably go faster. So there's a few settings that I need to change, and then I'll pull this off here. All right, this comes off the bed pretty easily now. You can see that this part here broke. I probably might have broken it when I was taking it off. There's a whole bunch of supports here. These supports might be difficult to take off, and so having less supports would be good. The supports come off pretty easily, although I'll need some kind of tool to get off the support. And so maybe while it's printing, I will practice support removal and see what it takes to remove the support. Whoops, I broke the part trying to. All right, so got to be delicate about support removal. I broke up this part trying to get rid of supports. Sizing seems okay. Since I broke the part, it's gonna be hard to size it exactly, but I spent a lot of time doing size calibration on this, and I'll show you how I did that when we get over to the focusing and calibration grid. So okay, I can put this aside now and we can start working on the slicing. Now, I drive my printer off of this Lenovo Tablet 2 here. And I typically don't run Creation Workshop on this particular machine. I will run Creation Workshop on my desktop machine and use this only to run the Kudo3D software and to control the printer directly. But for the ease of this video, I'll show you the process with Creation Workshop on this particular computer. So Creation Workshop has the ability to create supports and all that, and I did not use Creation Workshop to create supports. I used Mesh Mixer to create the supports. So all of the support changes, manually adding support to increase the structure, adding a reinforcement in the corner of support that broke during the last print. I didn't do any of that in Creation Workshop. I pretty much used Creation Workshop only for positioning the print and slicing. And so if you need some tutorial on how to create supports, there are a lot of videos on YouTube, and there's a lot of documentation and discussion in the Mesh Mixer forums about how to use Mesh Mixer for creating support. There are lots and lots of manual options for creating supports, defining support that supports other support, and doing all of that. I've already done that, and so what I'm going to do is I'm going to open up my STL file here, my iPhone 5 bumper supports, and I brought that in here. You'll see that it comes in, and Mesh Mixer, being an Autodesk product, likes to orient things the Autodesk way, which uses the z-axis and the y-axis differently than what we typically use for printing. The z-axis in this case is typically in an Autodesk product oriented like a monitor, where z would be the depth going into the monitor, whereas we would look at z as going, up and down, and that's why we see z working in this way. They treat z the kind of the computer graphics, the computer vision way, rather than the 3D printing and CNC tool control way. But that's fine. I'll come in here and I'll just rotate this around the x-axis by 90 degrees, and there we go. And then whoops, I hit it twice. See, it's laggy in the on the tablet. So now we go move. I'm going to center it, which of course sends it to the middle of the table, which isn't right. And so I'll hit this button to put it on the surface. And so now, what is the way that this is oriented, right? The X and Y axis inside Creation Workshop is basically the X and Y axis from the projector's perspective. And so if I were to look at this from above, right, this is from the projector's perspective, which means I'm looking at this from under the vat, looking up at the build plate, right? And that means that essentially, if this is the build plate that I've got, right, the axis here is looking at it like this, right, from the bottom of the build plate, and that means this side here is the back, the stationary end, and this side here is the front, the floating end of the vat, right? And so remember what I said earlier, I really want that lowest point to be at the floating end of the vat and not on the stationary end of the vat. But the way that I'm looking at this right now, it's over here in the corner, and that's over at the stationary end of the vat where the forces are the highest. And so I will need to rotate this 180 degrees around the z-axis in order to move this over to the floating end. So there we go. We've got this here. I might make a couple of minor tweaks that aren't necessarily entirely necessary, just to kind of position this in the part of my projector where I kind of optimize the focus, or not to, so it's not too far in one or another direction. So I'll move this maybe over to the left a bit, and then I think I'll move it down a bit. Yeah, so that's fine. Okay, so I've got it pretty much positioned where I want it to be in order to print. So I will save the scene, and saving the scene is important. You always want to save the scene. I'll overwrite the previous scene I've got here. Save, yes. And then I can slice, but before I slice, I want to show you these configuration options, and I might want to change them. These are configuration options I've set previously, but I want to show you what they are. So the first thing that's set is the machine. We want to set the display to be the configured display 1920 by 1080. That basically tells us the resolution of the projector, which is 1920 by 1080. I set that once and never change it again. I just use it each time. And then the other setting that matters on the machine is the build size, X, Y, Z. Z, I still have the original firmware, the 24 centimeter firmware, so the Z height I have set to 240. X and Y, you'll notice that I have set to these odd numbers. And that partially is the way that I configure the resolution of my setup. Some people out there are really into, if I show you the way that I have this set up, right, are really into getting the height to an exact level. And so they will print out guides in paper and then move the projector up and down. I'm not quite that particular about hitting an exact resolution. In reality, if my X is like 2-3 millimeters off different, the microns of resolution is pretty much going to be the same. So what I generally do is I will put the original calibration sheet into the vat. I've moved the projector up and down to approximately the height that I want, and get the size of the grid so that it's about the size that I wanted. I think I wanted about 145 millimeters. And then I level the projector. I try to rotate it so I get minimum keystoning, and then I lock it in place and I don't move it. And then I fine-tune the focus and the zoom in this position in order to get the best possible image, and then lock those in place also. Where I lock the focus really using the focus lock, the foam tube, which I'll show you while we're slicing. And then the foam wedge rather. And then I'll go back and measure and eyeball kind of down to the millimeter, the closest that I can guess. And then I make a presumption of 16 by 9 dimensions, which has worked out for me, and then I enter those into the X and Y. Then I'll print out a calibration part, and then after I print out the calibration part, I'll measure the calibration part with calipers, and then use this adjust. So I've been using the 30 by 30 calibration part, and then I'll use build size calibration. I'll say, okay, X size, Y size, that's 30 millimeters, the size of the model, and then I'll plug in the measured size, and then use this, and then it'll compute an adjustment factor that'll then adjust the X and Y dimensions to match what came out from the calibration part. And then I might do this a few times. Usually what I'll do is, I've got a calibration part that I've been trying to print in a particular orientation because I eventually want to produce molds, which will require me to create completely solid rectangular parts. And so I've been printing the calibration part to practice the settings that I'll need to print out completely solid parts. They usually come out slightly messed up, kind of like this guy here. I haven't actually yet been able to print out a really large rectangle at the orientation that I've wanted to. And I probably have to start playing with more tilting, like this iPhone case. And so I've printed a bunch of these, and then I'll measure the failed print. As long as you've got like a couple layers, you've got enough to measure. Then I've plugged it back in, and I've got the setup here dialed in so that I'm pretty close. My prints come out, my 30 millimeter parts come out within about a 1/10 of a millimeter. And so this is how I dial my calibration rather than using sheets. The machine connection, projector control, machine controls, you don't use any of these. In reality, in the machine profile, you only really care about making sure that you have the display and the build size set correctly. And then we've got the slicing profile. And the only important parameter in the slicing profile, the way that we print using the Kudo3D process, is a slice thickness in millimeters, right? This parameter here. This is the slice thickness you want, and this parameter is very important because you're going to, whatever value you set here, you're going to need to type in the same value in the Kudo3D software. There are a few other things that are kind of useful. The big one is that if you set all of these other parameters like the exposure time, an approximation of what bottom exposure is and bottom layers are going to be. This is of course an approximation because even in basic mode you can set 5 different layer regions in the Kudo3D software. In Creation Workshop only has the notion of bottom exposure versus rest of print exposure. The lift distance, lift speed, retract speeds, those are all constant for the entire print. Right? So the Creation Workshop is less functional in terms of different layer parameters in the Kudo3D software. So you set the bottom exposure and the Z, lift distance, and height to something that's like a reasonable estimate of the overall average of what you're accomplishing. And then when you hit AutoCalc, it'll compute this lift and sequence time, and it'll use this in order to generate a print time estimate. And that's pretty useful because then you get an idea of how long your print is going to take. And the closer you dial this in, the better it'll be. In my case, I'm going to come back and change my slice thickness to 0.05 millimeters, and then apply the changes. And so this is a change, and this is going to affect my settings later because I've printed before. I have a set of settings in the Kudo3D software that matches 0.075 millimeter slices. Since I've changed this to 0.05, I'm going to have to alter those in the software in the Kudo3D software when I get there. And so we go and come over here, back to the 3D view. I'm going to save this, overwrite the existing, and then I'm going to slice. 850 slices. And you'll notice that this is going pretty slow. You can see that number tick up. This goes like 5 times faster on my desktop computer. So this is going to take a while. And while this is going, I'm going to, I'll level the build plate and show you how I do focus. So I'll come over to the Kudo3D software here, and we've got a whole bunch of controls here. We've got enable Z0, go to Z home, Z up and down, right? We've got our Z controls, and we've got our I've got the projector controls, and then my build plate here. When I come over to my print setup, we'll see that I've got my build plate here, and then I've got the my printer, and there's no build plate connected to it. So I'm going to need to level the build plate, get the build plate on here, level it, and then double check the focus. So let me move the camera in position here. Okay. So, first thing I'm going to do then is I'm going to go Z plus up 10, 20, 30, 40, 50, 60, 70, 80. So I'm going to take this guy 80 millimeters up so that I can easily attach the build plate. So I got my build plate here, and then I want to get the build plate approximately level. So I'm going to take my handy dandy level here and go, oh, that's 0, and that's 0.1. So I've got the build plate level, and the reason why it's level here is because I didn't adjust this ball from my last print, right? So I had it set. What would have happened if I didn't, if this was off at a weird angle? So okay, let's get it off at a weird angle, and I'll get it approximately level here, and then leave it loose, right? And then I'm going to take the build plate down to the 0 I had before. Now, if this is the first time you're doing it, you're not just going to go straight to Z home, right? You're going to gradually move this down. And you're going to gradually move this down until you get close. And then once you get close, you'll hit enable Z0 and then move it down until you see that you are firmly against the bed. So let me lock the vat in. And when you put the vat in, they tell you, okay, push the bed all the way up against the screw. One thing when you push this bed all the way against the screw is that this screw here makes contact with this flexible wall here. You don't really want it pushing really hard against the screw because that'll cause the film to kind of bow out and put stress on the glue. So you kind of want to get it touching, but you don't want it to have a lot of pressure against this because this end of the vat, right, is going to be flopping up and down. And you don't want when it flops up and down for it to catch the edge of this film on the screw. I've noticed that in a couple of prints I did, I had it really rammed hard against there, and the film was kind of bowing out to the side. I didn't have a catastrophic vat failure, but it seems safer to not have to not push it all the way in. And then I'm pushing this against the back because I do want it flush against the back, and then I'll tighten these guys down. And you know, there, it's nice and firm. And so, and I'll take this down. I'm gonna go straight down to Z home. I'm pretty confident in the Z0 system. It's never failed me yet. It hasn't crushed my vat going down. But there is a procedure for you to kind of take this thing down to physical 0, and then you kind of maneuver the system so that it's there. And then let's see. So where are we at now? So now I'm pretty much against the vat, and then I'll come and double check with my level here where I am, and I'm pretty level at 0. And the reason why I can check with this level is because when I leveled the 4 feet, right, the casters, I leveled the feet, I measured levelness based upon the build plate pushing down on the vat, right? And so the way that I would then fully zero the build plate is now that I've got it close, I'll go enable Z0 and then nudge the 0 down until I make firm contact with the vat, and this thing is pretty stationary. And then once this thing is pretty stationary, I'll level the vat. I leveled the feet. So I'll move this in, and as always when you're tightening something, and this is true like even on a precision CNC or a precision like a manual milling machine, you want to crank this one down gradually so that you don't push it off kilter while you're tightening it. And then I'll move up 10 millimeters, and I'm level. So my build plate now is level against the vat. The vat's levelness is pretty repeatable. So I don't have any problems where like the levelness of the vat relative to the casters that I've leveled previously somehow go off, or the vat is changing thickness, or if it's warping or whatever. When the vat is under slight pressure from the build plate at 0, it's very repeatable. Its angle is very repeatable, and so I leave everything here, don't move it, and I can trust the go to Z home. So I've got this set up now. I've got my vat level, I've got Z0 set, and I've got I've got it raised 10 millimeters. Actually, I'm going to show you focus. So I'm going to take this back down to Z0 so that I can take a look. So we can take a look at the focus. So I'm going to get the tripod again, and then we're going to set it down here, and then we're going to move it so that we can look up. There we go. So now we are looking up at the bottom of the build plate. And so now I'm going to hit power on the projector control. And that's the projector going on. I don't have any resin in the vat, so I can take off the build plate protector, which is really the acrylic build plate that I use for my Printerbot Junior. And this is, of course, you see this Acer logo. This is, of course, why it's important to keep that covered, because you don't want Acer burned into the first layer of your print. I'm about halfway done slicing. So this is, of course, why I don't slice on the tablet, because even after all of this talking and rigmarole, I'm only half done slicing this thing, and it's not even that big. Let's see here. What did I do? Oh, I swapped cables and stuff previously. So I probably accidentally switched my computer from HDMI to HDMI 1 to HDMI 2. Yeah, so there we go. Normally you wouldn't have to mess with this. Once you had the source set once, you'd be good. So here we go. Spot focus on, so I need that bright spot right in the center. It's probably still too bright for you to really see on the camera, but what I'm seeing here is a Windows desktop. So I'll hit calibrate, and now we see there's the calibration image is being displayed, and I'm looking down. Since my build plate is pushed right against the bed, this will allow me to calibrate the focus of the build plate, and then I can calibrate the focus basically by adjusting the ratio between the zoom lever, the second lever here, and the focus ring here. You notice that I've got the foam wedge in there, I've got the focus lock in there. And even though I love you guys, I am not actually going to mess with this because I have it locked in pretty much where I want it. I do have the zoom lever off kind of to the left. The recommended setting is to have the zoom kind of in the middle and then adjust the focus perfect. And so I had it initially there, but of course when you put the wedge in, it moves the focus a bit, and so I had to move the zoom a little bit out in order to get it nice and good. And then I've kind of optimized the focus here so that it's still pretty sharp in the center. It's not quite as sharp in the center as it could, because I want to avoid a super aspherical part right in the corner here. I guess the part right behind the fan. And that's really off when the center is perfect. And so I've kind of averaged it out a bit. I still get I still get good resolution of my prints, so I haven't had any problems yet. And then I haven't had to worry too much about avoiding any particular spots. It's definitely still the case that the projector is way sharper in the, from the projector's point of view, the bottom, right, which means this edge here, than it is on the top, which is this edge here. And this generally is a factor of the way that the projector optics are designed, because you're supposed to be able to put this on a table and then project it against the wall, but your table is not going to be so high that it's, you know, in the middle of the wall. It's designed to throw an image such that the bottom of the image is relatively flush with the level of the projector, and the top goes up from there. And so the top is designed to kind of be in focus further away. Everything is a little bit, I mean, we're so close here, right? And so everything's a little bit different in our setup, and so we see the aspherical sphericity of the projector more clearly in this setup. But this is how I would do my final focus of the view, especially because our build plate is nice and black, so we get good contrast. Alternative ways of doing this. Yeah, I'm gonna have to blob on a bit because we're still slicing. Alternative ways of doing this. You can always print out calibration sheets. So if you wanted a very, very specific dimension, you can print out a calibration grid. There's a couple of them that have been posted to the Kudo3D forums. You can cut it out and then you can put it into the vat, and then you'll move the projector up or down to match that and try to get perfectly in focus. It's a bit of a dance, which is why I don't do it, because you have to kind of get the focus, zoom, and height, get these three things all locked in the right place with the exact right size that you want. And so if you move the projector and you have the size you want, you lock the projector in, then when you get the focus and zoom the way you want it, you'll find the size of the grid change a little bit. Okay, now I'm gonna have to move the projector again, and that's a bit of a dance, and I don't find it worthwhile. If I can get it within a millimeter or two, that's good enough, and I'll do the rest of the calibration through calibration parts rather than trying to match a printed calibration grid. But other people on the forums have had success this way, and so if you like, if you want to do it that way, that's fine too. The important thing, and this is a suggestion from Vince on the forums, which helped me out a lot when I was first starting, is that you want to check the focus from the bottom, projected against a paper or the. Great, so the slicing finished finally, and I'm back at my computer, and we can take a look at the slicing directory that got output. We've got generated a whole bunch of image files which the Kudo3D software will take as input. Before we do that, we have to delete the 0th file in here. Whoops, messed that one up. I missed. Delete. Now that's gone. We can open this up in the Kudo3D software. So I'll come up here to File, Load Model, and I'll come over to my Models directory and open the directory that contains the files. You can select any one of these and we'll recognize we've got 849 layers in here. But the settings are a little bit different than what I had last time. The most important one here is the layer thickness. It's now sliced at 0.05 instead of 0.075. So come on, 0.05. So there we go, 0.05. And then I'm going to load up the set of importing the layer configuration that I had for my last print, which worked pretty well, but I'm going to have to modify it. So unfortunately, you're not necessarily going to be able to duplicate my settings exactly. I'm using fun to do industrial blend resin that I bought from Craig Turley's Studio Cubed. And I bought it in unpigmented, and then I used some black pigment, some multi-resin pigment from Tap Plastics. I added about, I think about maybe 1.5% by weight, something like that. Anyway, it's pretty opaque, but it's also not exactly the same as any other resin that you might buy off the shelf. So these are the settings that I've eventually dialed in. And actually, because there's quite a lot of pigment in here, because the resin is quite opaque, I am quite, the resin is quite forgiving of overexposure. And so if I give it a little bit too much, like the difference between 4 seconds, 6 seconds, and 15 seconds, can't really tell much of a difference. 4 seconds is great because it's faster. But even up to 15 seconds, I don't get a massive amount of overexposure. Even at the 35-second attachment layer, there's only a little bit of fringing at that layer. So let's take a look at what we have here. I've got my attachment layer from layer 1 to 2, and so I still want that. 35-second exposure, 8mm lift, a very, very gentle 15 millimeters per minute up speed. And then I have the upper attachment layers, which previously go from 3 to 10. Layer 10 would be 0.75 millimeters up. This also isn't, I probably don't need to change this all that much. Maybe I'll increase this a little bit to layer 12. And I probably didn't even need to change that, so I'll leave that there. And then there's the support layer. So I'm going to need to minus this, then plus it back in to recompute that layer. And this minusing and plussing for the next layer whenever you change a previous layer is important. Even if you get the from layers and to layers precisely aligned, unless you did flipped this plus and minus, the Kudo3D software will complain about a discontinuous layer designation. And so whenever you change any of these numbers, and a lot of times I'll just flip them all off and flip them all back on to recheck them. I'll do that because even if I get the numbers correct, software will complain unless you do it. So here from layer 13 to layer 42, these are the settings that I use for the support region, from the distance between the support and then the first couple of layers of the print. And so the support layers here, at least up to the very bottom part, go up to 3 millimeters. So so Mesh Mixer will always generate supports that are a minimum of 3 millimeters tall. And previously that meant, I think, somewhere around layer 40, but now 3 millimeters is at 0.05 is clearly layer 60. And 0.05 millimeter layers is easier to the math in your head. And so I want to go up to layer 60 at least. And then I'm actually going to go a little higher than that. I'm going to go over to layer maybe 64 to get a couple extra layers in to make sure that the attachment points are good and strong. And that'll give me a 6-second exposure. Now in reality, I'm going thinner layers now. And thinner layers, in theory, you can do less exposure by a small amount of time. I think that if you have the layer thickness, you can reduce the exposure by 1/4 by 25%, something like that. But I'm not actually going to change these at all because I'm pretty flexible with overexposure. I'm pretty much going to leave this the same. I'll go 6 millimeters of lift here, and then go down to the next section. Now the next section is going to be originally just building the whole rest of my model, but there was definitely optimizations here for speed. I didn't need to build this slowly for the entire model. And so instead of going over, right, 566 used to be my highest layer. Now I need to go over to 849. I used to just go all the way up with this. So when I'm 3 millimeters up now. But I'm not going to do that for this print. I'm going to go up to about maybe 130 with these settings. 4-second exposure, 4 millimeter lift, and then use different timings for the rest of it. I'm going to stick with 4-second exposure, but I'm only going to lift now 2.5 millimeters up, and I'm going to go up faster. I'm going to go up at the 50 millimeters per second and go down at 150 with a 1-second delay. And that'll hopefully print out my remaining layers a little faster. And then my projector's off. While I was off camera, I turned off the projector. I was done focusing. And what I am going to do to make sure that I don't get surprised right when I'm ready to go with everything with a discontinuous layer designation is I'm going to hit run, and it'll go, and it's printing. I can see that it's printing because it's got this preview. This preview window is not always exactly precise. I'm going to hit stop now. And I just wanted to run that to make sure that it would run when I was ready to go. And I'm going to double check the output window here. Did the stop not take? Stop. Stop. There we go. You can hear the sound off to the right. That's the layer going up. So that's good. I am ready to fill the vat with resin and then start printing. So I'm going to come up here, go over to control, power on my projector, and then I'm going to stick the blocking guy over it, and that'll put me in a ready to print phase here. Oops. And then I'm going to have to go to Z home before I print, so I'll stick on this screen. And so one thing is that the printer will start printing wherever it happens to be. And so if I'm 10 millimeters in the air and I hit run, it's going to start printing there, even if the build plate is not at 0. So you've got to make sure to go to 0 home before you print. But since I haven't put any resin into the vat yet, I can't be at Z home now because I got to get some resin underneath the build plate. So I'm gonna let's move the camera over here so that we can take a look at the process of filling the vat and setting up the print. move the camera off a little further away so you guys don't have such a zoomed in view and you can see a little more clearly what's going on here. Okay. So I've got the good old build plate in here. I'm going to double check actually that when I hit calibrate, oops, that it turns red, full screen, yep, so I'm good there. And I always check that because sometimes the window that is used to print can get messed up, resized, whatever. So you always want to check right before you print that when you hit calibrate, you get a full screen view of the calibration image. Shake up my resin, swirl it a bit, and then I'm going to fill. I'm going to put some down. Fill them over there. Gradually it's going to flow. I don't want to get this thing super full. A little left-handed pouring. All right, and then wipe off the rim here. Close this guy up. All right, got resin in there. I'll take this down to Z home. And lift it. Make sure that resin's nice and evenly spread. Take it back down to Z home. So now I am in there and ready to print. I'm going to put this down here, give you a little view of what it looks like when we start up. From underneath. And this is what I'm usually looking at when I first start, is making sure that this bottom layer looks right. And so now I am at Z0. I'm going to come here, I'm going to pull this off, then hit run. And then now I should be able to see, yep, the attachment layer is going down. And the Kudo3D software does a good job of computing the estimated time, since it knows, the settings here. The problem is that once you've changed the settings, it won't estimate the time until you run. Since I have run, estimated time is 2 hours and 37 minutes, so that should be pretty good. I'm not going to sit through the whole thing, but I am going to watch the setup part very closely. So our attachment layers, our attachment layer, right? In this case, since I went 1 to 2, I've got 2 attachment layers. Usually go down fine because we've set them to really large numbers, right? 35 is pretty big for fun to do resin. You often set it to 60 for other resins, or if you're following the guide. So that's going to stick to the build plate fine. And then we're looking at we want to watch the way that the build goes, and the way the vat lifts. And then we also want to listen to make sure that we don't hear we don't want to hear supports ripping off. We do want to hear some good detachment. Whoops. So I will set this up now somewhere where we can get a decent view of this. Sorry for the moving camera while I get the attachment all firmed up. All right. That's okay, I can get a little bit closer. Let's see here. The other thing you can look at is you can look at the bottom of the vat, particularly for the separation layers, the long exposure and big parts. After the light goes out, when the vat starts pulling up, you should be able to see the spot where there's a big piece. It'll darken, and it'll darken kind of as it pulls up and starts to form a vacuum. And then it should eventually go from dark to resin colored as the part pulls off the vat. If you see a dark shadow on the vat and it stays dark, then you might suspect that you have a print failure where a part got stuck onto the vat. So I'm on layer 6 now, halfway through my 15-second upper attachment layers. And these seem pretty well stuck on, so like no problems here. I'm gonna put some of the walls back on. I took all the walls off. I've got this tripod that will easily tie to the corner, to the T-slot extrusions. So I'm gonna have to leave some of these sides off, but I guess I'll put some of these back on. Then I've got the orange cover off right now just to make it easier for you guys to see what's going on. Because of course if I put the cover on, it'll become that much harder to see clearly what's going on, and then you'll lose all sense of color and everything. So normally I would have put this on as soon as I filled the vat, but I'll leave it off for now so that we can take a look. The resin isn't going to, first it's evening right now, and I have these low color temperature lights that don't really put out anything in the 400 to 420 nanometer area, so I shouldn't have much ambient UV. And the resin isn't going to kind of just suddenly set instantly at room temperature. Well, partly I have pigments in here, so the light's not just going to go shoot all the way through it. but you're not going to see it like magically skinning up on the outside just from ambient light. The ambient light is much less intense than the light coming out from the projector. Oh, look, I trapped a bubble under there. Bubbles will go away. Partly just because I pushed down the vat into the surface of the resin really fast. I should have kind of slowly moved it up or down a bit. My part, because it's circular and it's mostly, empty space, the bubble isn't any place important. If you had a solid object, you might care more. But in reality, you're almost always going to need to stand your object up on supports, which means that by the time you hit like 3 millimeters up, there aren't going to be any bubbles left. By the time this thing goes up and down, after a while, all the voids will have gotten sucked out. There we go. And I could actually see it in there. On this end, right, I could see a shadow formed by the denser supports that I manually put in here, and then the shadow disappeared just right when I heard that drop, which means as there's tension pulling out, you can see it, and then once they release and the resin makes the surface uniform, and then we saw those go away. It can be harder to see that when the supports are not as dense. So the less dense supports along the back, right, close to the stationary end of the vat, those I can't really see clearly this way. But after a couple of layers, if you have some kind of delamination part sticking to the vat, there's a good chance that you can see it along the bottom side. Now my resin's highly pigmented and very opaque, so it may be unusually difficult to see things compared to resins that are less pigmented, a little bit more translucent. You might be able to see more. I remember I was watching a YouTube video from 2012 of a very, very transparent pigment being cured by a research lab with a DLP projector. And you could see the resin curing as the light hit it. Because the resin cures fast, right? In our case, eventually we'll be curing the resin in about 4 seconds. And you can see the phase change occur. In this murky black goo, you're not going to see anything. So we have to use deduction to figure out what's going on. because of the nature of supports, this part here is not likely to fail. So I'll stop the recording here and we'll come back when we get closer to layer 60-ish when we start getting to the part. Alright, so here we are now at layer 65, and the corner of the iPhone case should start building now. This is where be really concerned about any potential delamination. This is where all the times it's failed where the actual body of the case started building on the vat floor instead of attached to the supports and coming up on the build plate properly. So there's a large area in the corner. I'm checking to see if I see any signs of it coming off. And so far it's hopeful. You can see that this corner here is sticking a little bit more, that it pulls up. This, well, it kind of mostly was the same. Previous layer, this side here came down a little bit first, and then this side came a little bit after. So at least I think this corner here is still adhered. And there's a technique that you can do that I use sparingly. I've never had any software problems with it. I did once get the case where for some reason I got a film form at the layer where I did it, but it could have been a random thing. Is I can pause the print, goes back down, and this is the level at which the next exposure will be taken. Then I can go up by 10 millimeters, and then I can see, and that actually looks pretty good. The corner is there and it's nice and solid. And then I'll go down by 10 to take it back to where it was before. And then I'll hit continue. So that looks pretty good. We'll let it go. And I guess the next major excitement will be around layer 130 when we switch to the new accelerated settings. Right now I'm lifting 4 millimeters. And you'll notice I'm dropping less than halfway through the raise sequence. If you count, I count to about 7 Mississippi for the whole raise sequence, and it drops somewhere around 3. And so at layer 130, I've got the accelerated lift with only 2.5 millimeters of lift going up significantly faster. This lift now is going up at 35 millimeters a minute, and that will go up to 50 millimeters a minute. So layer 130 will be the next exciting point. So here we are at layer 204 in the highest speed area. So here's where I'm doing still 4-second exposure, but only 2.5 millimeters of lift at 50 millimeters a minute. So far seems okay. It's a very definitive snap as the layer detaches. 2.5 millimeters seems sufficient. And so this is going to go on for another 200 or so layers. So at this point, let's see, I can see, yeah, the side is forming nicely. You may not be able to see anything really clearly now. So I'll wait for it to build up a little bit more, and then take the camera for a walk around. So we're back at layer 739 out of 849. So we've got a little over 100 layers to go, and there's quite a bit of the print is done. So we can look at how this has printed so far while it's going. This part is a bit more exciting because we can actually see the part rising out. It's not a total mystery. I did not need to add anything to the vat. I think the vat, the amount of initial resin added to the vat is sufficient. Since we only have 100 layers to go, there will be no problems. And then I'll take a walk around, show you what the print looks like from different angles. as we work our way to the back, we can see that the problematic support from last time is fully attached. So that support on the far, in this case on the far right corner of the screen, which would mean on the really the right rear corner from the perspective of the printer, that one seems to be fine. It's there and it's holding on to the corners fairly well, so I don't see any of the warping that I saw before with the previous print. Maybe this will give you a better view here from above, how there's very little warping there. Another thing to notice is that opening where the buttons are. The top part of that was kind of warped in the first print that I showed you, and so I added a bunch of supports to hold that in place, and now we can see that both the top and the bottom of that button opening are perfectly parallel. So those supports did help hold on to that. They will create a problem that might be tricky, in that if you look at that, the surface, the width of that area, the upper part of that button opening, is about the same diameter as the supports. So I'm going to have to be very careful when removing supports and not break that. In general, I think the experience that we saw at the beginning of this video, when I was examining and breaking off the supports, is that this part in particular has a bunch of delicate pieces on it, and so I'll have to be careful when removing support, and in order to not break those delicate pieces. So I'll reposition back here so we can take a look at what this looks like from behind. And really it's that rear corner. If we were looking straight at the printer, it would be the rear left corner. That's what's left here. The angling makes sure that we don't have too big of a surface area on any given layer. And so there's a chance that I won't catch the end of this print in the act. What happens at the end of a print is pretty simple. The projector will turn off and the build plate will rise by 10 centimeters. And so the projector will turn off, and then this thing will go, well, basically let's go way up, and then it'll dangle there with the cover on. There you could just sit there, and so a lot of people will do this overnight. So you could let this run overnight, come back and check. Of course, if you had a failure in the middle, you would have no idea. It would just keep on going. But in theory, an experienced printer who knew that the part was going to work, you could leave it, it'll raise up, resin will stop curing, no more UV will get in because you have the cover on. The projector will turn off, so you won't have any residual light coming in, and you could just leave it. As expected, I slightly missed it. So I heard it go off in the other room, came back, and the print is done. And as I heard it go off, when the projector turns on and off, it makes this beeping sound. And so I heard the beeping sound go off, and this now raised all the way up. And now we see it come off the build plate, and I can now clean up the print. I'll take a quick walk around of the item on the build plate just to wrap this up, since you've seen you can watch the cleanup process for another part in the other cleanup video that I have. That cleanup video, of course, is the extra step of removing a failed print, a broken part off the bottom of that. And fortunately for a print like this, which was successful, we would not need any such step. So we'll take a look here. Oops, at the bottom. Moved the printer accidentally by leaning too hard against it. We can see here the print off the bottom, and there's some resin dripping off, but otherwise the print seems intact. There don't seem to be any missing parts. The supports all appear to be intact. And then let's see if I can give you a view from underneath without getting my camera all resinous. It's an under part view, and then we can see kind of under the part what the part looks like attached to the build plate. And so that's now a completed print. I'll have to rinse it off quickly in alcohol. Probably only want to do it a little bit, swish it around a little bit, and then I'll put it into the UV chamber to fully set it. Once that's done, and I'll do all of that with the parts still attached to the print bed. Once I'm done with that, then I'll go about trying to figure out how to remove the supports without breaking the part. It probably won't be very hard, just means I'll have to go carefully with needle nose pliers, piece by piece, in order to break off the supports cleanly without breaking anything. And so that is the end of the print. Thanks for watching. Hope it helps.